And this was, I think, a very interesting study done in this aspect. Now, going over the methodological overview, as I said, we can see in this graphical representation that there is a feedback loop in the whole architecture. We start with the user, and via their chats and via their queries and problem, like the questions they're asking and their way of speaking, there is a trust estimation. Like the initial first few chats, there is a trust estimation done that how much the user is relying on the chatbot, or like how much they're like agreeing with it or disagreeing with it, the way they are interacting with it basically. And based on that, there is a adaptive intervention there, which we will get to know the particular metrics of it. Now, on this, after this adaptive intervention done on like from the AI side, it notices the decision made by the human, right? Like what do we choose to do after that intervention is done, and that final answer, that final choice is it updates that trust metric, which we can see as the parameter one adjusted. It changes, it updates that metric, and it feeds back to the entire loop of the architecture, so that that metric can further affect that adaptive intervention. It can be further personalized for the particular person doing it. And overall, this was a very, as I said, it's a very trust adaptive framework, and it had a very personalized experience for every user, and it didn't give the same explanation to everyone. They had a like they had manually set in the particular metric. If it was less than 5, as we can see, it categorized it as low trust, and then it would provide supporting explanations. And if the metric they found after the measuring of the user trust was above 8, then like that might be a case of high trust or over reliance. So in that case, the chatbot would give a counter explanation, that is an explanation of the other situations or the other like the other stakes that might happen if the answer is incorrect. If the answer, if the trust metric fell in between 5 and 8, that was like determined as a moderate trust, and which is like a normal test case scenario. So in that case, no intervention was done and the chat proceeded normally. And from this flowchart, again, we can see this particular flow of the architecture, like from the decision task to the initial answer the user gave, it was saved, and the initial recommendation the AI gave again, the prediction plus the confidence. Now, this measure user trust thing is the novel introduction this paper made, again, the trust metric. And based on the supporting explanation or the counter explanation, whatever the user decides finally, it updates the trust score, and it again feeds back into the next interaction. And again, the exact flow of it changed from person to person, because the way this flowchart would like go for a particular chat is again dependent on how the user reacts and interacts with the chatbot. So the authors in the paper discussed a very critical and very important scenario actually. As I explained, there was the low user trust and high user trust examples. And in our daily life, it can be some very trivial or very simple cases, right? Like whether we are asking some advice on maybe some homework, right? Maybe some maths homework or science homework that we are doing. It can be something very trivial. And but the cases that were discussed in the paper, those are of I would say some pretty significant importance. And one of the main cases they discussed was of a medical scenario in which the like the doctor or the medical representative, they are asking the chatbot for a particular diagnosis given um, a set of symptoms, or maybe at times the documents, the x-rays, the charts, etc. And in this case, we will discuss the two cases that happened on the two extreme ends, right? Our case studies. In both the cases, the AI recommendation was pneumonia, right? But in one case, there was a chance of under reliance in which the user was skeptical. And like from the previous chat, the chatbot determined that maybe there's a case of under reliance, and it would then provide a supporting explanation, like as we can see here, it would say like why it is determining that the diagnosis is pneumonia, based on which charts or which symptoms it is diagnosing that. At times it would even give mathematical metrics, right? Like the probability of this being the case, maybe a 75% probability, maybe a 90% probability. And based on what it is giving that metric, it would like explain the reasoning behind its answer. But again, if from the beginning the chatbot felt that um, the trust metric was very high and the user was perhaps over relying on the chatbot, then it would add some counter explanation, some counter examples with the answer. Like here, although pneumonia might be a possible case, tuberculosis or maybe some other diseases as well might happen because some of the systems are overlapping. So in this case, it would add in some extra scenarios with the original answer, so that the user are given, like the user is forced to kind of think for themselves as well, and there is a chance of lowering their trust metric here. And it basically depended on their trust levels to determine which kind of AI assistance the user would get. Uh, Now we will like go through the flow of the particular experiment in detail, like the way they designed it. They had both like normal users or lay users as well as medical professionals, because as I said, like most of the cases discussed in the paper were of a medical background or from a medical point of view. And they had included medical professionals like doctors or nurses in it, as well as like normal users. And they used various data sets into the entire program, like arc, reasoning questions, diagnosis, the charts, and some medical data as well, because it was mostly focused on that domain. Initial step was of obviously recruiting the participants, then of giving them a decision task, a particular question that they will be dealing with. In this case, determining the diagnosis of a particular case study, and like all through the AI chatbot. And then there's the initial human answer, like what they think the answer is. After which they then consult the particular AI model for its recommendation based on the same given set of information and questions. Uh, Now, based on that, and the from the conversation till now, it gives an answer, a recommendation, and from the like answer of the user, like whether they're agreeing with it or disagreeing with it, there is an adaptive intervention done, as in whether it's giving like whether it's giving um, like an under relying case study answer or an over reliance case study answer based on the trust metric. And based on that, they again note the final human decision, the final answer the user is giving. And overall, it gets a trust rating from 0 to 10. This trust rating again is fed back, which I said, and the normal trust rating as they defined was from the range of 5 to 8. Right. Okay, so they had different experimental conditions in it as well. There was the no intervention or baseline case study, in which there was only the prediction and just the user confidence metric given. There was another case wherein the model always gave only supporting explanation answers. That is, considering this case that the user might be always under relying on the model. So it's always giving extra explanations, extra reasoning, extra like metrics behind why the answer might be correct from after every prediction. And the purpose was to test if constantly explaining might help with proper and unbiased decisions. The other test case was counter explanation always, in which case there is the particular answer the AI model is giving, but apart from that, it is also giving all possible cases that might be possible in every answer after every prediction. And the reason for this was again to measure uh, if constant counter explanations help. And then again was the novel model that they are mentioning, trust adaptive intervention, which is the explanation that is based on the current trust level, which is based on the entire chat history that's happened, and that is their proposed method of this paper. And they had defined 4 particular evaluation metrics of the final decision accuracy, under reliance, over reliance, and the total inappropriate reliance. And from the baseline, we can see the 4 particular conditions here. The baseline, always explain, always counter, trust adaptive, and then finally compare the results we get from the 4 types of test cases. Now, this was the first experiment, which is under reliance with supporting explanations. That is, the AI model is always giving extra explanations, irrespective of the kind of answers it's getting. And it was found that in the cases wherein the supporting explanation was adaptive, was much more effective than always giving the same explanation. That is, 100 like giving extra explanations in 100% of the cases was less effective than when the particular model was built upon the particular chat history itself and it adapted to the particular user trust case. In this, right, so when for the users that were relying too less on AI and were a bit skeptical, from this particular experiment, they found these particular metrics. And overall, they saw that only when the user trust is low, it improved the decision quality. The next experiment was the other extreme case, that is always giving counter explanations. And it was again only found most effective when the user trust was already very high. So only when the user was already relying too much on the AI model was this particular experiment the most successful, that is giving counter explanation always. And in this case also they found particular metrics, that is how much giving explaining the overall situations helped with uh, explaining the overall situations helped with sorry, where was I? One second. Right, so sorry, I'm really sorry. How it helped with the overall inappropriate reliance. And then again was the main 2 experiments that they did. That was a trust adaptive method. Now I'm saying 2 experiments because they again introduced another particular scenario, which was in experiment 4, and that is simply displaying AI is thinking and adding a time buffer before the particular result or the particular answer was shown. In this case, there wasn't much of an intervention from the trust metric itself. Like the answer itself wasn't much changed, but the time the time buffer itself was increased, and it was after a few seconds of delay that the answer was shown, and it was shown that AI is thinking. Now, this did not help if the user was already a bit skeptical, right? But in the cases that the user was blindly relying on AI, it did increase, like it did better the test results a bit, because in that case, the user got a time frame to actually think about the problem themselves, rather than just waiting for an instant answer from the AI chatbot. And the experiment 3 was the one that I have explained a bit earlier. That is when the trust metric was less than 5 or more than 8, depending upon the under reliance or over reliance situations. It would provide supporting or counter explanations. And in these two cases, like combining both experiment 3 and 4, they found the best results. That is, an adaptive method was found to be the most helpful for this particular experiments. And the last one was built upon the, like, experiment 5 was kind of built upon from the experiments 3 and 4, in which it was a more personalized chat, like a more personalized chat experience, wherein the chat history itself had a bit more relevance with it. And as we can see from the metrics itself, that this was found to be the most helpful, and the decision accuracy actually increased from like about 10% from 10 units, like from 58.4% to 67.8%. And the inappropriate reliance overall decreased quite a lot from 83.5% to 68.2%. Both under reliance and over reliance cases reduced significantly in this case. And for the experimental setup, as they described, they used Llama 3.18B assistant, ARC reasoning benchmark, and for each condition or each setup, they used 30 participants in this. So from their overall study and the final results of their experiments, we can see that giving supporting explanations or like adding the reasoning behind the answers really helps when the user is a bit skeptical of the AI model. And on the other hand, counter explaining when the user is over relying on the model also helps to balance out the results. And based on both these two methods, the trust adaptive strategy, that is their final mixed model, is the was found to be the best performing strategy, wherein the intervention was based on the user's trust level, and it consistently achieved the best overall performance. And wherever this particular framework was used, they saw that the decision quality was found to be better and more accurate than in cases wherein under reliance or over reliance interfered too much. Now, discussing the strengths and the limitations of the particular study, this actually addressed a really practical problem in human AI collaboration, wherein they considered a metric that is actually pretty much hard to define, trust itself. It's a pretty, humane metric, I would say, that they had tried to add into the mathematical model. And the framework was rather simple, but it was found to be pretty much effective, and it was also like it's a very much extendable framework that can be added with multiple AI assistants. It can be scaled, and from all their findings, their proposed framework, it did perform the best. Like it was the best performing strategy out of all the particular test cases. But there were some significant limitations as well, mainly concerning with the size, like the dataset size. That is, it had very limited participants of only 30 people per scenario, and also the trust thresholds, which is the one of the main factors in this case, was like manually selected, and it was manually hard coded. So it might depend quite a lot from particular AI model to model, and it might need a lot of fine tuning depending on the model it is being attached, like used with. And the entire experiment was, since the like the data set size, the experimentation limit, it was quite pretty small, so it was a very controlled environment, and there might be some like multiple real world factors that weren't being able to considered in this particular finding. And also the trust itself, like one of the main metrics, it was self-reported. So there is again that particular factor that there might be misrepresentation in the self-reported ratings. But if the data set size is increased, and maybe more people are engaged with this particular experiment, with this particular study, perhaps more real world factors and inputs will be introduced into the strategy and the framework, and maybe a more robust framework can be given from this. But the strategy and the proposal in itself is pretty much novel and promising, and it did leave some pretty solid impacts. Now, discussing the future works of this particular study, one of the main things is actually integrating multiple more real world factors into it, integrating maybe this particular trust aware prompting into more advanced agents, LLM agents, validating the particular framework in the long term, because this was again a very controlled experiment, and predicting, like this particular study was based on ratings instead of automatic predictions. So automating the whole process will also help into this, like extending this trust adaptation into this multimodal framework. Now, finally, moving on towards the conclusions, we can see that, like, we finally reached a conclusion that yes, user trust does directly influence how we as humans are interacting with AI models and AI recommendations, and it is a very much important factor of how we are actually responding to the answers we get and the decisions we make. Number two, the adaptations, like the adaptive interventions introduced through the study, were found to be effective in both the extreme cases that they had explained of under reliance and over reliance. And three, that trust aware AI, it's a pretty important step towards a human and AI collaboration, and it is something that I would say fall under the human computer integration kind of thing, and it is a domain that definitely needs more representation and much more focus, because it would definitely address some of the ethical concerns of AI as well, and maybe make it a much more reliable uh, like a much more reliable source of information for us in general. And again, finally, the objective was not to maximize the trust, but to balance it properly as it should be in both real life and with AI models. So that I would like to conclude my presentation. Thank you everyone for listening to me till now.
Thank you, Anwesha. That was really a wonderful presentation. Now, if anybody is having any doubts regarding the presentation, they can ask her now. Uh, and Anwesha, I also am having some doubts. I want to clear.
Question, Bhanu?
Yes, sir.
Yeah, I have one doubt to ask. Is this one a scalar value? This trust kind of scores,
Yes, it was a hard coded value in this case.
like all of these values, the values that we get, all of their scalar values, right? Like
Yes,
some kind of point 5, 0.273,
yes.
like okay, okay, okay.
Anwesha, how are we getting these trust values? Like these are self created trust values.
Yes.
On what basis?
Okay, so this first of all, this range in itself was like it was manually input, like that less than 5 or greater than 8, and the particular metrics that we can see, it was self-reported, as we discussed in one of the limitations of the study. That sorry,
Yes,
I
that self-reported trust value, how we are getting those values, even if it is self-reported, is that every user is mentioning the trust value of that particular result according to their effect. Is it
uh,
like that or something else?
It is a kind of it is a kind of hypothesis, I guess.
Yes, like in this case, actually, mainly because the test case was so small, they relied a lot more on like manual intervention or like self-reported data in this case. It was only after this metric, like that less than 5 and greater than 8, after those metric were like introduced, kind of, or they were categorized, that the particular, I would say, the model comes into view, because based on that metric, it is then that the model is changing its answers. So everything before that first metric comes in, that whether the user is under relying or over relying, it is a bit like it is like self-reported in this case.
Mhm. So wouldn't it be better if we are using any formula apart
Yeah.
instead of
Look,
these?
look, look,
Yes, yes,
look.
yes.
If you have any kind of standard kind of work formula, then you can obviously go. But I guess they did not had such things in mind, or maybe they have not studied the background. So that's why they have done all sorts of experiment now to get the best results, and to get a paper. They have those values like 5 and 8.
Yes, yes.
That is my guess. Okay,
Like
after
they
doing all
did
this.
mention that automating this process was mentioned in their future work, like automating the entire
Yeah,
data
yeah.
collection process.
No, not the data collection, but
Yes,
the
the
thing that the Bhanu just told. If we have some kind of predefined rules,
metric, right? So it
if
can be
yeah, yeah,
much more
rules, metrics,
universal.
if those are the things available, and placing those things in your total flow of work, that would have been better. But as they might not had that one, so they have gone in this way. Is this
Yes.
a journal paper or a conference paper?
This was so the journal, if I'm not wrong.
Okay, okay.
Okay.
Anwesha, uh,
Yes, ma'am.
here you have talked about the trust calibration, right?
Yes, ma'am.
So, is it possible that cultural difference can affect this trust calibration?
It might be possible. I mean, in this case, again, they had a very limited experimentation case, and they mostly focused on medical cases.
Okay.
Like, even the data set themselves here, it was mostly focused on medical decision making, the charts and etc. So herein, maybe in the factor of cultural differences might not be that relevant, but when we are talking about scaling this in the real world and actual implementations, then yes, um, it's very much relevant, I would say, and that is again maybe another metric that needs to be included in this, that needs to be thought about before assigning the particular trust's value.
Okay. So, I just wanted to ask you another question. That have you gone through the paper and there is any statistical test in the paper?
Statistical test wise, they actually just they had shown these experiment values
Okay.
mostly.
Okay. Thank you. If anybody else has any question, you can ask her.
One more question, Anwesha.
Yes.
If we are implementing this in a real world scenario, hasn't it be a bit of manipulative also for some users? Like, suppose a user is getting a result which is right, and it is in under the trust score of below 5. Okay, and the other result for the same thing is above 8 of trust score. The right one lies below 5, but the user would prefer the more trusted score metric now. So he might go for that one.
Wait. The you were saying that the correct answer falls in the category of less than 5 in the trust score,
Mhm.
like whatever the AI model is given, right?
He's getting the uh, AI predictions for that also, like जो AI लेस देन 5 के लिए उस रिजल्ट को बढ़ा के बताने का कोशिश कर रहा हो, दैट वन ही इज गेटिंग द पॉइंट, but he's also seeing that the another result is above 8 score, and he's getting convinced for that one. Then what happens? um,
Um, I mean, in general, if you're talking about one particular user in one particular chat, it's actually, I think, more the case that they will only see one version of the answer. Like if they're opening two different chats and interacting differently, they might come through different answers. But in one particular chat, uh, they will get one answer, right, based on the previous conversation. But I think, like, I can somewhat understand the question you're aiming at, like this segregation. It might result in like some manipulation in the answers, right? Like if two different people are like sitting with it. I think like when we are implementing this in the real world, as with like many features of AI, some caution must be taken. One feature that might be introduced is, I think, something that we actually see nowadays in most of the AI chat models, like ChatGPT and many other models. That is, we can actually choose which version is working better for us, or
says
like
the responses we can choose, but the most of the data in those responses are same. And also one more thing, you said in a slide that it is compatible with different chatbots, so we can integrate it with ChatGPT or Gemini also, right?
yes, like they suggested that since the framework is comparatively simple, it can be extended to multiple models.
Just one thing I'm having doubts regarding is everything is in this project is manually intervened.
Yes, that is one of the limitations actually. This does need more work. It needs like much more experimentation. But I think the direction that they started in, it is worth looking into. Again, the question you were like, I think trying to ask before, like maybe I wasn't able to answer that properly. But like what I'm trying to say is, the users should be aware of the feature itself, right? Like they should be made aware of the feature that there is this trust metric thing introduced in the model. And if they do not want it, maybe there should be a feature to turn it off. Like there are multiple personalization methods in different models, right? So if this particular strategy is introduced in a model, the users do have a right to know that this is there. And if they don't think that, like if they think they don't want it, it's something they don't want in their answers, then they should have the the choice to turn it off. Like I think that should help with a more unbiased experience with everyone.
Mhm. Okay, thank you, Anwesha. Anyone else is having any questions? You can ask now. Anyone?
If anyone has any question, please ask her. Anisha, I have one question. Like it is to you actually. In this paper, all the measures are self-reported, right?
Yes, ma'am.
So, do you think it is like a reliable measure? Can we rely on this if it is implemented in the real world? should we or can we rely on this, since all of these are self-reported?
Based on this particular study itself, I would say no, because that's not a very statistically sound thing to do. But like the main reason why I chose this particular paper for this reading session today was the topic itself. And okay, I might be a bit biased in this, but my previous work regarding AI, it was more on detecting misconduct, like detecting it was more on the negative impact of AI and how we can detect the presence of AI in a negative sense. But I
Yes.
think this is in a much more positive light. Like if more research is done on this, and if maybe more industry appropriate standards are brought into this framework, and it's actually built into the models, I think it would really help with the scenario I'm personally most concerned with is the over reliance, because that never really helps. Skepticism, if you have the knowledge about the particular domain, maybe it is okay if you're a bit skeptical about the particular thing. But if you don't have, like, if you are wrong, like if your decision is wrong and you're relying on the AI answer, which unfortunately happens to be wrong as well, some kind of, I think, metric needs to be introduced in this. And I found this particular study a bit novel in that case, which is why I wanted to introduce it in today's session. But yes, statistically, this needs much more work.
Yes, I guess this one is a pretty, like, this one is like a research gap. We can show, if we take this paper for some literature review, we can show the research gap through this.
Yes, ma'am. Yes, ma'am. Yes.
Thank you.
Yes, ma'am. Thank you.
If anybody else has any question for Anwesha, please ask. Nobody has any question? Okay. Bhanu, you should carry on.
Okay, then we are concluding this reading session now. Thank you so much, Anwesha, for such a nice, helpful, and engaging session. I would also like to thank everyone for joining us today and actively participating in the discussion. Also, one of the link will be shared in the group for attendance, so everyone is requested to fill that Google Sheet. Your attendance will be marked for that. And with that, we come to the end of the 8-week session. I also request all the students to actually positively engage with the speaker so that you can also clear your doubts more clearly and understand what things are there which you don't understand. Every paper comes with a novel perspective and new terms which you might not know, so it's a better chance to improve yourself and your doubts.
This is a very important thing what Bhanu said. I would request all the students, everyone here present, that all the students specifically, that please ask questions, even if it is the stupidest question you can find. No question is a stupid question. Just ask. Nobody is going to judge you here. Just ask what you need to know.
The whole goal of this reading session is that you can clear your doubts regarding the terms which you don't know. Means how are
Exactly.
you going to implement in your projects those things which you are needed but you don't know about them. You are listening but not asking.
Listen what the speaker is saying. Ask them what you need to know. Connect them after the reading session so that if you have any doubt, they can make you clear the doubts. You can implement that in your research work or in your project, whatever you are going to do in future. Thank you everyone for joining. Please fill the feedback form. Thank you. You can leave.
Have a great day.